let's talk about one of the biggest and coolest shifts happening in cloud security right now. It's the idea of going completely secretless. Now, what does that mean? It means no more static passwords, no more API keys just sitting in config files, and absolutely no more long-lived credentials that can be leaked or stolen. It sounds kind of impossible, right? Well, stick around because it's not. So, to get us started, let's chew on a fascinating puzzle. Imagine you've got an app, say a Lambda function running over an Amazon's cloud. It needs to securely talk to another app, maybe an Azure function running in Microsoft's cloud. How in the world do they prove who they are to each other across that cloud divide, with absolutely zero shared passwords between them? You know, the way we used to do this, and honestly the way a lot of systems still do it, was with static secrets. You just generate an API key or a password. You'd stick it in your application's configuration file, and you just kind of hope for the best. But these things are a massive liability. They get accidentally checked into GitHub, they get stale, and if an attacker gets their hands on one, they basically have the keys to the kingdom. It's just a fragile, high-risk way of doing things. To solve this, we have to completely flip our thinking. Instead of giving our software a key that can be lost or stolen, we need to give it an identity. The best analogy is a passport. A passport proves who you are, it's issued by a trusted government, and it lets you get access to other countries. Well, we can do the exact same thing for our software. And the fancy official name for this software passport system is Workload Identity Federation. At its core, it's really just a trust agreement between different identity providers, like AWS and Azure. It allows a piece of software in one cloud to prove who it is and get permission to access stuff in the other. And here's the crucial part. Access is granted based on who the software is, not what secret it knows. All right, theory is great, but let's make this real. We're going to walk through that exact example, our AWS Lambda calling an Azure function step by step. Let's see how this secretless handshake actually plays out. Okay, so first things first, our Lambda function in AWS needs to prove it is who it says it is. It makes a quick call to the local AWS identity service and basically says, hey, it's me. Can you vouch for me? AWS looks it up, confirms its identity, and issues a special short-lived identity token. Think of it like a temporary single-use ID card. The Lambda then takes that AWS token and presents it right at the front door of Azure's identity service. Now, this is where the trust federation kicks in. Azure doesn't just blindly accept this token from a stranger. It checks back with AWS to validate it, asking, hey, did you really just issue this ID card to this specific Lambda? And because we've pre-configured a trust relationship, AWS says, yep, that's legit. Once it's validated, Azure does a quick exchange. It takes that AWS identity token and issues its own temporary access token, one that's only good inside the Azure world. And for the grand finale, our AWS Lambda now uses that brand new Azure-specific token to make its call to the Azure function. The function sees a valid Azure token, trusts it, and grants access. And just like that, success. We have a secure, authenticated cross-cloud call, and not a single long-lived password was ever stored or sent over the wire. This whole identity dance happened in just a few milliseconds. So what we just walked through was a specific example using a standard called OpenID Connect, or OIDC. But this identity-based approach is really just one tool in a bigger playbook for going secretless. There are actually a few key patterns you can use, depending on what you're trying to do. This table breaks it down really nicely. The OIDC pattern we just saw is like a hotel keycard. It's perfect for getting temporary access to a specific service, especially when you're crossing boundaries, like from one cloud to another. Then you've got MTLS, or mutual TLS. I like to think of this as a secret handshake because both the client and the server show each other cryptographic certificates to prove their identity at the same time. It's fantastic for locking down communication inside your own network. And finally, there's SPIFFE and SPIRE, which is like a universal ID card that works absolutely everywhere. And it's the real foundation for building a true zero-trust network. And it's really worth zooming in on SPIFFE and SPIRE for just a second, because this is such a powerful idea. SPIFFE is the open standard. It's the rulebook for what a universal workload ID should look like. And SPIRE is the actual open source software that brings it to life. The magic of SPIRE is that it can run anywhere, any cloud, on-prem, in Kubernetes, you name it. And it automatically handles issuing and rotating these super strong cryptographic identities for all of your software. It takes the burden completely off your developers and gives you one consistent identity system across your entire infrastructure. So we've gone deep into the how, but the why is really what makes this such a game changer. Why go through all this trouble to give your software a passport? What is the real payoff here? The benefits are just huge. I mean, first and foremost, you completely eliminate the #1 cause of major cloud breaches, leaked secrets. That whole risk category just vanishes. You also automate your security. No more humans needing to remember to rotate keys, which means no more human error. This makes things like compliance and auditing so much simpler, and it lets you build systems where every single request gets its own dynamic, short-lived credential, valid only for that one task. And really, if you remember one thing, it's this idea right here. For decades, our entire security model was about protecting secrets, locking them in vaults, encrypting them, rotating them constantly. But workload identity lets us take a huge leap forward. The most secure secret is, and always will be, the one that never existed in the first place. And that leaves us with a final thought to ponder. We've just established that we can give our software a strong, provable identity. So what's next? If your software can prove exactly who it is, what other incredibly powerful security policies, fine-grained authorizations, and dynamic controls can you build on top of that foundation? The future isn't just about being secretless. It's about being identity-driven.